prove some permutations. We need to prove that this permutation is equal to essentially these two here. In order to do that,
trick.
well, in order to do that, we got to see what
true.
a permutation is, right? And we know that a permutation, you're looking at the first term, which is n factorial, so n factorial over n minus, this would usually be the r factorial, so n minus r, and then factorial. But in this case, I should have put these in here. Put these like this, n and r, so that we know what we're talking about. So this would be the n we're talking about, because in this question we've used different letters. And this would be the r. Well, the r in this case happens to be n also. So in other words, this here is really, when we work it all out, it becomes n factorial over n minus n factorial, and that just becomes 0 factorial, which is 1. So this is n factorial. Okay, so we got to know that on the left side. So with our right side, we can replace these permutations with kind of this formula we have. And this formula is identical to what that is. So we have n factorial over n minus r factorial. Okay, so think of this like the very first term. We've replaced that npr with this. These are factorial values we use. Whoops, and that factorial should be outside the brackets, not inside.
Can a factorial ever be inside brackets? Or
Sure,
is it,
yeah,
okay.
yeah. It's just that's the way this permutation formula is set up.
Okay.
And then in our other one, our n value, okay, this is our n value. That was our n value. This is our r value. This was the r value. So the n value here is n minus r factorial divided by n minus r, subtract the r now is n minus r, and then all of that is to a factorial. Now we saw that when both values are the same on the bottom, like we had here, it becomes 0 factorial, which is just the value of 1. So we're only left with what's on top here. So we can simplify this second value already. So we'll leave this as is, n factorial over n minus r factorial. And this term here is really just n minus r factorial. Put it in brackets, okay? So I know we're only using variables. I guess we could use numbers to simplify the idea. But now we're going to multiply this in. And because we don't know what they are, think of them just like x and y's, right? I got kind of too many brackets here on the, well, actually not technically because I have an factorial here. But if I'm going to multiply this across, think of it like we're multiplying fractions. There is technically a 1 on the bottom. We know this is a 1. So we multiply the top by the top and the bottom by the bottom. So you're left with n factorial times n minus r factorial. And all of that is
n squared and then nr.
well, no, we won't distribute because of that factorial.
Oh, okay.
Think of it more like this: n minus r factorial. There's multiplication in here. Okay, so because there's multiplication, think of it like the idea if you have 2 times 5 divided by 5. Well, I can just cancel out the 5s. They essentially create a 1, and we're left with just the value on top. And if you're unsure about that, really it's 10 divided by 5, which is 2. So the fastest way to do that is to eliminate those things. And because these two things here, I'll highlight them, are identical,
Well, they cancel.
they cancel out.
Yeah.
And because they cancel out, you're left with just n factorial, which is exactly what we proved the other side to be, n factorial. So this is really just not so much working with a permutation, but this is like simplifying variables, this question.
Mm-hmm.
Simplifying variables to prove that something is equal to the other. Because that was kind of confusing. Another way we could do this is we'll use some let statements. So we're going to say like let, whoops, that's not how you spell let. I want to use the letter x, but let x equal n factorial. So we're going to replace all of the n factorials, there's only one, with the letter x. And we'll say let y equal n minus r factorial. So we're going to replace all of those combinations with the letter y. So that's 1, 2, 3, 4. Sorry, and I don't want the factorials actually in the let statement. We just want the n's and the r's. Okay. So with that being said, we now have x factorial. Okay, divided by n minus r, we're replacing with y. So just y factorial. And on top, we have y factorial divided by, this is y, subtract y factorial. So y minus y, oops, I didn't get that, factorial, okay? Now that we've set that up, we're going to simplify the value on the right. So we have x factorial, divide y factorial over y minus y is 0, right?
Yeah.
So 0 factorial, which is essentially just going to be that value of 1. So in
Yep.
the next one, we'll write it that way. So we have x factorial over y factorial times really y factorial over 1. And these are multiplied by each other. So when you multiply fractions, we're looking at the top by the top, bottom by the bottom.
Oh, x factorial.
Yeah, so this
y
is where we're
factorial.
going to end up, yeah, exactly where we were before. X
Yeah.
factorial, y factorial, whoops, over
Y.
y factorial. Those create the 1, and we're left with the x factorial. And really, that's the n factorial.
Yeah.
So sometimes when you have sets of brackets like that, it's much easier to write a let statement and just simplify it as one variable.
Yeah.